Okay, so this is a video with some example problems similar to the ones that are assigned for homework. So let's look at, these are all tangent transformations. So let's say have y equals the tangent of 4 times the tangent of x. So the only thing that we have that's different than the parent function is this multiplier out front. And so that's going to result in a vertical stretch. And there's really only 2 points that are involved in that. That's the I guess we call it the 8th period, and that's going to end up being -4, and the 3/8 period is going to be +4, because in the normal parent function the value at these points are -1 and +1. Okay, so let's make this thing. So because we're stretching in the vertical direction, what I'm going to do is just change the scale. So normally we probably have at least 4 units in the vertical direction. So I'm going to change that to, let's say let's just do it 8. Okay. So we're going to go up 8 and down 8. Now the first thing we do is we draw our vertical asymptotes. Well, first what we do is we draw the one period to the right of the origin and one period to the left of the origin. The period is the same thing as we did for these other functions, so it's the multiplier in front of x. So what we have is a is equal to 1, and therefore the period is 2 pi divided by a, or just 2 pi divided by 1, or 2 pi. Okay, so we'll go plus 2 pi, and we'll go minus 2 pi. And then we break the period up into 4 equal parts. So half of 2 pi is pi, half of pi is pi over 2. So then we count 1 pi over 2, 2 pi over 2, 3 pi over 2. And because we're doing it symmetric around the origin, it's going to be negative pi, 2 pi is negative pi. This is negative pi over 2. This is negative 3 pi over 2 for the x-axis. Now, we have vertical asymptotes every half period. So we hit the half period. So what is a half period? Half period, half t is equal to pi. We also know that the tangent of 0 is 0. Why do we know that? Well, because the tangent is the sine over the cosine. And the sine of 0 is 0, and the cosine of 0 is 1, so 0 divided by 1 is 0. So that is a point. And that is in the midpoint of the 2 vertical asymptotes. So what we can do is we can go this, basically if we have this period as a whole, is units of pi as a whole pi unit. If we go from negative pi over 2 to positive pi over 2, we'll have the correct distance to draw the vertical asymptotes. And once you've got 2 in, the rest of them are the same. You just keep doing it. So I'm going to go to negative pi over 2. So that's, you can see we have the 0 between the 2 vertical asymptotes. The distance between the vertical asymptotes is half the period, which is pi. And now we can just continue to do vertical asymptotes every pi units. So there's my vertical asymptotes. And then you can draw the x-intercepts right in the middle. Now the next part is where we use this amplitude. So I said At 1/8 of a period, we go to -4. So remember, the general shape of a tangent function looks like that. So we're going to have to fit that in here. So if this is 8 units, this is negative. That's -4. That's +4. So it should be -8 there. -4. So I'll use green here. So we go 8th period, which is between the vertical asymptote and the intercept, and that goes down to -4. And then if you go the other direction, halfway, you go up to 4. And then we can draw in the tangent type look. And then between each vertical set of vertical asymptotes, you have the same shape in the same direction, the symmetry. So then you can just draw in as many as you have room for. And because we're doing 2 full periods, we can have that happen a total of 4 times. 2 periods would give you 4 half periods. We're actually showing 5 half periods because we went a little bit out. Okay, so that's that particular one. The parent function would, instead of having this point at 4, it would be down at 1. So this and then a -1. So it would be a much squished version, because what we're doing here is we're vertically stretching it because of this number. Okay, the second one we're going to look at is y is equal to 2 times the tangent of 2x minus 1. So the -1's outside of the parentheses. So this has to do with the amplitude, or we can call it the vertical stretch. Just like this 4 in the previous problem was the vertical stretch. This 2 is going to affect the period. That's A. So this thing is what we call capital A. This is small a. And this was C. C is this is going to be the vertical shift. So there's no horizontal shift. There's no reflections across any axes. So again, what we'll do is we'll do them to the right of the origin. In this case, we've been doing alternating between the 2 options. So we want to go 2 periods, so we need to figure out what the period of this thing is. So the period is equal to 2 pi divided by a. In our case, a was 2, so we have 2 pi divided by 2, which is pi. So that's the period. So if we want to do 2 periods, that's 2 pi. And 1 period is pi. And then we break it up into quarter periods. So we first do a half, so you have pi over 2. Do it again, half pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Let's put some marks in here. It's always easier to divide something in half. So we have, that's 5 pi over 4, 6 pi over 4, which is 3 pi over 2, 6 pi over 4, 7 pi over 4. So those are all equally spaced pi over 4 units. Now the vertical asymptotes, to go back to this last problem, notice the half period was pi, and we went then a quarter period either side of the x-intercept. So we'll do the same thing here. We'll draw our vertical asymptotes, and the tangent of 0 is 0. We're going to do the vertical shift kind kind of at the end here. I just want to set up the asymptotes now. So normally if you put in 0, you'd get 0. In this case, you're going to get a -1. So, but you get a 0. This is kind of the midpoint. So we're going to move quarter of the period over. Actually, yeah, because what we want is the distances between the vertical asymptotes to be okay. So let's think about this. Well, the distance between the vertical asymptotes distance is equal to t over 2. So we get pi divided by 2. And so if we have this 0 point, which is at the midway, to get the distance between the vertical asymptotes, we would go negative pi over 4, positive pi over 4. That distance would give me pi over 2, which is the distance that I talked about there. So I've got that in the correct location. And then you'd go another half period to the next half the period is pi over 2. So you add pi over 2 to get that, and then you add pi over 2. And you can see how if these things aren't equally spaced, then you've done something wrong. Side. So there are our vertical asymptotes, and got this 0 point. Again, I'm going to change this when we do the vertical shift. So let's go ahead and put in the points, and then we'll shift everything vertically. Now notice I've got this amplitude of 2, so remember I did twice this. The last problem is 4, and now it's 2, so I went up and down. But I do have this additional shift thing, so maybe I'll go plus or minus 6 instead. So if I do 2, 4, 6, and do the same thing, negative 2, 4, negative 6. So without the vertical shift, I would go over halfway between the x-intercept and the vertical asymptote, and I would go up 2 units. The parent function would go up 1 unit. Over here I go to the left halfway, go down here, and then you just repeat the same pattern through each one of these situations. Like that. So that's the green. Now what I'm going to do now is I'm going to shift it vertically -1 unit. So this will go down to there, this one goes to there, and this one goes to there. And so if I draw a line, a curve through these points, I'll get something like that. And I could just copy this blue point, so just moving everything down 1 unit again. So this goes from 0 to -1, this goes from -2 to -3, this goes from 2 to 1, and then I can draw through those. So, I've shown these 3 points are important, and you just have to then, once you've got the 3 points in the vertical asymptotes, you can draw a pretty decent representation of a tangent function. So let's kind of review what we did here. This number, because it was greater than 1, it shrunk in the x direction. So it moved these vertical asymptotes together by a factor of 2. This changed where the quarter period and the three-quarter period, well, negative, yeah, if you go one direction, quarter period, in the same way the other direction, instead of going to 1, the tangent of 45 or tangent of pi over 4 is 1. Because of this we go 2 units up, so that stretches it in the vertical direction. And then I had this vertical shift of -1, so I moved all the points down 1 unit, so that they, after they've stretched, they've shifted down 1. Okay, next one is y is equal to negative the tangent of 1/2 x minus pi over 4. So this negative is going to be an x-axis. This is an x-axis reflection. This is going to affect the period, and this number, once we factor out the half, is going to affect the x shift. So we haven't done an x shift yet. But whenever you have an x shift, you have to factor out whatever that coefficient is in front of the x. So we'll factor out a half, and you do the same. You divide this by a half, which is the same as multiplying by 2. And you can see if I take a half times negative pi over 2, I get negative pi over 4. So we can, again, the negatives, the x-axis reflection, small a is a half, so the period is equal to 2 pi divided by half, which is the same as 4 pi. So in this case I'm stretching it in the x direction. And then b over a, so this is b, this is a. If they, when I factor it, b over a is going to be equal to pi over 2, and that's my x shift. Plus, so I'm going to move everything in the x direction. And what we'll do is we'll move the vertical asymptotes, and then we'll do everything based on that. Okay, so what did we do last time? We did to the right, so we're going to do symmetric around the origin. So what's the period? The period is 4 pi. So we're going to go 4 pi in the positive direction and 4 pi in the negative direction. As far as the amplitude is 1, so it's probably just as good to put 1 and 2 here, and -1 and -2 here. And so we can break this up into quarters. So half of 2 pi is 4 pi is 2 pi, half of 2 pi is 1 pi. 1, 2, 3 pi, and then we have the same thing going in the other direction. Minus 2 pi, minus pi, minus 3 pi. And normally our vertical asymptotes, so we're just going to think about the vertical asymptotes. Normally the tangent goes through 0, and then we have vertical asymptotes a quarter of period either direction from that 0. But in our case, we're going to shift everything pi over 2. So let's go ahead and draw them in where they would normally be. That would be the normal location, and this would be the normal location without the x shift. So what we do is we'd shift them a quarter period to the right, which is going to be not a quarter period, but pi over 4. So this, pi over 2, yeah. So this whole from here to here is a pi, so halfway is pi over 2. So I move from here to halfway, pi over 2. Same thing, I move that over here. This green dot gets moved over, so that's the 0. And then what we can do is we can go halfway between the 0 and the asymptote, which will be pi, and because the amplitude is 1, we go up to there. And likewise, if we go pi over 2 this way, we'll go to, I need to move this over a little bit, it's not quite between the two. This one's a little bit off. Okay, that's better. So then we would normally be up here and down there, but we've got this x-axis reflection, so because this is on the axis, it doesn't get reflected. This point will go down here to -1. This is the intercept, this is +1, and so then we can draw in the tangent for half of the period. And then we can take the vertical asymptotes and move them. So we remember the half period is 2 pi. 1 period is 4 pi. So half period is 2 pi. So we go, and each mark is pi. So if we go here, that's pi. 2 pi, that's where we put it. Do the same thing over here. 1 pi, 2 pi in that direction. And we can go 1 pi, 2 pi. These are a little bit outside. We can do the same thing over here. 1 pi, 2 pi, that's way over here. So we may not even want that in there. Okay. So now that we've got these things, we just repeat everything. So the 0 goes through there, it's going to go through there, and there, and then we go halfway between these two, and then up 1 to match that, go down 1 to match that. So then you have that thing goes come like that. And just repeat the pattern. Like that. Do one over here. Okay. So again, let's review. This half made it so the full period was 4 pi instead of 2 pi. We drew where the origin, where the x-intercept, tangent of 0 is 0 point, but then we offset that by the x shift, which turned out to be pi over 2, not pi over 4, so we always have to look at this version. So we move that pi over 2 to the left, and then the vertical asymptotes were plus or minus a quarter period. Well, total period is 4 pi, so a quarter of 4 pi is pi. So we went pi this way and we went pi that way. Then once you have those two, you can go pi, pi, actually 2 pi. So we went pi this way, pi that. Its total distance is 2 pi. So we go 2 pi, 2 pi, 2 pi, 2 pi. Then you get all the vertical asymptotes. And finally you can, after you got the zeros that are halfway between the two vertical asymptotes, you can then put these extra 2 points, and those are based upon the amplitude, which were those points, these light ones, and then we reflected them across the x-axis to get the final one. So this actually looks more like a cotangent type function because it's starting up here and going down there. So there is that relationship. You know, the inverse, the tangent and the cotangent are related one way is because they're reflected across the x-axis. Okay, 2 more. So this is y equals the tangent of -4x. So this just has this affects the period, and this is a y-axis reflection. So this negative here is y-axis. And this number, that's the number A, and that relates to the period. So the period is 2 pi divided by 4. A is 4. So you get pi over 2. So that's, instead of the period being 2 pi, it's 1/4 of that, pi over 2. So let's draw our thing, we're switching back to the 2 periods to the right of the origin. So if 1 period is 2 pi, pi over 2, then 2 periods is pi. Halfway is 1 period, that's pi over 2. We cut it in half again, it's pi over 4, pi over 8. And so one I don't know why I said 8, I wrote 4th. So it's pi over 8. 1 8, 2 8s, 3 8s, 4 8s, and then we'll mark these off. So 4 8s, 5 8s, 6 8s, so that's 3/4. 6 8s is 3/4, and this is 7 8s. So we're going by 8ths of pi. Okay, so that is the period stuff. Now, normally we have 0, and if I put 0 in here, I'm going to get the tangent of 0 is 0, so we'll have a point here, which is the x-intercept. And we move plus or minus a quarter period. A quarter period is pi over 8. Normally a quarter period is pi over 2, but you take a 1/4 of that because of this 4. So we'll go here and so we go quarter period there, quarter period the other direction, and then we go a half period and another half period. You can see how these are all consistently spaced apart. Okay, so that was, and then we'll, normal tangent function would go up, would start down and then move upward from left to right. So it would kind of look like this. But what we're doing is we're going to reflect it across the y-axis. So instead of reflecting across the x-axis, we're going to reflect across the y-axis, which essentially is the same thing. And then we got the 3 points, so we can draw in those 3 points with the vertical asymptote. You can get it look like that, and then all the other ones are just repeats. So again, this one we went over halfway between up 1. If this were something other than 1 times the tangent, then we'd have to stretch them or shrink them. So see the symmetry, inherent symmetry in these situations. Okay, so that's it. But again, it's like y equals x cubed. This says symmetry. If you flip across the y-axis, it's the same as flipping across the x-axis. And these kind of have a similar kind of behavior. They don't. This doesn't have any vertical asymptotes, but you are normally moving from negative infinity through the x-axis up to positive infinity. It's just smushed into between the vertical asymptotes. Okay, and the last one is y is equal to 2 tangent of pi x minus pi over 2 plus 1. So we don't have any reflections because this is positive and this is positive. We do have an x-axis shift, we have a y-axis vertical shift, and we have a amplitude. So a is equal to 2, which just means this is a vertical stretch. And this is, well, again, when you have a constant in front of x, you've got to factor it out. So we'd have to have pi times x minus 1/2 plus 1. And you can see it works out. If I multiply pi times x, I'll get pi x, and if I multiply pi times negative 1/2, I get negative pi over 2. So this is the A, which is the vertical stretching or horizontal stretching. This one is the x shift, which is going to be negative 1/2, and this is the vertical shift. So that's going to be plus 1. Okay, so we're back to being symmetric around the origin. So we're going to, well, we haven't done the period yet, so here's A. So the period is equals 2 pi over A. So we get 2 pi divided by pi, which is 2. So that's our amplitude, that's our period. So we're going to go from 0 to 1 period, which is 2, and then we go the other direction, so it's negative 2. So that's a full period. Then we break it in half, and then half again, and then we go half, 1, 3 halves. And then we have the same thing happening on the negative side, negative 1/2, negative 1, negative 3 halves. Okay. Now we're going to have this x shift, which we're going to reflect through the vertical asymptotes. Now normally we would have this point, which would be the tangent of 0 is 0, and then we'd have two vertical asymptotes, one that goes to the left a quarter period and one that goes to the right a quarter period, such that the distance between the vertical asymptotes is half a period. But what we're doing is we're shifting this thing a half unit, and it's actually not minus a half, it's plus a half, because it's x minus h, so that's plus a half. So what we're going to do is we're going to move these half a unit to the right, and then we can do all the other ones. So we're going to create another asymptote, half a period that way, half a period that way, half a period that way. Okay, so this was used to fix the distance between the vertical asymptotes and determine the scale. This number is going to determine the stretch in the vertical direction. So normally we'd go like 2, 4, because this is 2, so I'm just doubling it, and that's probably okay. So if we put 2 marks here, this is 2, this is 4, this is negative 2, this is negative 4. So we're going to lightly put in what would be the values without the vertical shift. So, you know, we have zeros between, let's just do one of these. So we have zeros halfway between the vertical asymptotes. We then go halfway between the 0 and the vertical asymptote, and we go up to, and we do the other direction down to. So that's without any vertical shift. But what we're going to do is we're going to shift them up 1 unit. So this one gets moved up to there. This one is moved up to there. This one gets moved up to there. And then I'm going to make big dots so I can see them easily. So you'll come up, you go through that dot, you go through here, then you'll come up through the other big dot. So that's the curve, and then we can just copy over the values relative to halfway between vertical asymptotes and then the quarter points. Over here, so you notice these are all aligned at the same y values. And then once we have those points in the vertical asymptotes, we can draw in these curves. That's it. Okay, so those are the examples that I have for you. There are some matching things at the beginning of the homework. You just have to see if you can figure it out. There's some cosecant, secant, and tangent and cotangent. And we talked about the difference in the characteristics of those kinds of things, so you should be able to at least narrow it down to either tangent or cotangent or secant or cosecant. And then thinking about, we know what the tangent function looks like. The cotangent goes the other direction, from left to right. And the secant and the cosecant are just shifted horizontally. So go back and look at the notes if you're having some hard time figuring that out.